For the reaction, rate equation is given. This is the rate law expression or the rate equation. The rate constant value is given. They are asking you to find the initial rate of reaction when A is A concentration, B concentration, you have to take as given. And calculate the rate of reaction after A is reduced to 0.04 m. This problem is, we have to find the rate. Here rate is asked, not rate constant. So we have to know when A is 0.04 m, we are starting with 0.1 molar A. And A and B react in the ratio 2:1. So when A is reduced from 0.1 to 0.4, what will be the concentration of B left out? That we have to find out first. That is not given in the problem. So find out the remaining B first and then subtract it from the original concentration of B and get the B left out at time t. Okay. And use that for the calculation of rate. So first let us calculate initial rate of reaction. Initial rate of this particular reaction R is equal to K into concentration of A at that initial time, A into concentration of B. So that is rate constant value they have already given, 2 into 10 power minus 6 into A concentration initially is 0.1, B concentration initially is 0.2. But A concentration they have told rate expression A raised to the power 2. So now simplify this and you will get 2 into 10 power minus 1 into 10 power minus 1 whole square. This we can write it as 2 into 10 power minus 1. So this will become 10 power minus 2. Again 10 power minus 1. You have to add all these powers. Minus 1, minus 2, minus 1. So total power is how much? 10 power minus 4. And these numbers you have to multiply 2 into 4. So the rate of the initial rate is, already you have 10 power minus 4 here. And here again there is a 10 power minus 6. 6 and 4 added together will become 10 power minus 10. So the rate of the reaction will be 4 into 10 power minus 10 moles per liter per second. Okay. Now next another rate they are asking. So initially we are taking A and B like this. 0.1, B is taken 0.2. But when A keeps on reacting and B keeps on reacting, they get reduced in concentration. So they are telling when A concentration alone is 0.04. That means from 0.1, how much of A has reacted? 0.06 has reacted. Okay. So initially taken amount minus reacted amount, when you subtract, you get the remaining amount. Similarly, we have to find remaining amount, remaining concentration for B also. But we know that they react in the mole ratio 2:1. That means if 0.06 is reacting for A and half of that will only react for B. So it is 0. Half of this is 0.03, no. Okay. So 0.2 minus 0.03 will be 0.17. Substitute these concentrations here. R is equal to 0.04 K into 0.04 the whole square into 0.17 power 1. So K value is not unchanged. It is 2 into 10 power minus 6. So the new rate, see always we should understand that the rate will decrease with respect to time. So in the value of a new rate should be lesser because A concentration is keeping on increasing. B concentration also keeping on increasing. So 2 into 10 power minus 6 into this, we can write it as 4 into 10 power minus 2 the whole square. And this we can write as 0.17. So simplify the powers. 10 power minus 4 will come. 10 power minus 6 is there. So this product is 10 power minus 10. 2 into 4 squared. 4 squared is what? 16. 16 into 2, 32. 32 into 17 is how much? 15. 22, 30. So 544. Okay. We have to keep the decimal place after 2 places. So it is 32 into 0.17 is 3.44. So the answer is 3.44 into 10 power minus 2. So originally the rate was 4 into 10 power minus 10. Now it got reduced to 3.44 into 10 power minus 10. Understand? For a first order reaction, show that the time required for 99% completion is twice the time required for completion of the 90%. This is also very important question. So first let us write time required for 99%. How much is it? 2.303 by k log of k values and all not given. So right away write the formula. Log R naught by, they have not given the reaction. So 99% completion means how much is remaining? Just 1% is remaining. Okay. So instead of R naught, whenever percentage is given, you take R naught to be 100. Remaining is 1%. No, put it as 1. Log 100 by 1 is 100 only. We can write it as 10 squared. And we can simplify this as 2 log 10. The result of this will be just 2. So T 99% will be 2.303 by K log 2. Similarly, for 90% you find out 2.303 by K log of 100 by 10. You get log 10 is 1. So this will simplify as 2.303 by K into 1. The previous one was 2.303 by K into 2. Not log 2, simply 2. So when you take the ratio of, whenever you are comparing, you are asked to compare two things, take the ratio. So how will you write? T 99% by T 90% is 2 into 2.303 by K. This one is just 2.303 by K. These two will get cut. So T 99% is 2 times T 90%. That's what is asked. T 99% is 2 times T 90%. Following data were obtained for first order thermal decomposition rate to of a constant volume. Calculate the rate constant. How will you do this? Here pressure, gaseous reaction means K can be expressed in terms of pressure of reactant. So at time T and initial pressure, we can use that to calculate K. 2.303 by T log of R naught by R. Sorry, instead of R naught by R, we use P naught by P. That P naught is the pressure of reactant at initial stage. And P is the pressure of reactant at time T. Okay. So 2.303 by time is 100 log of P naught is 0.5. This is total pressure. See, when the reaction proceeds, the reactant concentration keeps on decreasing. So its pressure keeps on decreasing. but the pressure due to these two builds up. These two keeps on forming newly, no? So the pressure due to the products keeps on increasing. So at one point, at 100 seconds time, all these three will be in the container. Okay, reactant as well as the two products will be there in the container. So the total pressure of all of this at 100 seconds time is only given. Okay, now from this we have to find the pressure due to this reactant alone. How to find it? For that we have to find the exact pressure. So we take initial at time 100 seconds. And the reactant is N2O5, N2O4, O2. N2O5 initial pressure is how much? 0.5. Initially, these two are not formed, so keep 0, 0. And pressure of N2O5 at the time T is what? See, supposing the pressure, stoichiometric coefficient, whatever is there, take that into X. So 2 into some X value. We don't know by how much it has decreased. So we take it as the decrease in pressure as 2x for from the original pressure. The pressure of N2O5 has decreased by 2x. So 0.5 minus 2x. Sorry. For a step extra change in pressure, and initial change in pressure என்ன change ஆயிருக்கு add ஆயிருக்கா subtract ஆயிருக்கான்னு பார்த்தா you will get the pressure at 100 seconds. Okay, so change in pressure is minus 2x for reactant, but for the product it is stoichiometric coefficient is 2, no? So here plus 2x and here x. So pressure at 100 seconds is minus 2x, here 2x, here x. So all added together 0.5 minus 2x plus 2x plus x. Add all this. So these two will get cancelled because this is minus 2x, this is plus 2x. Stoichiometric coefficient same. So this is decreasing here, increasing here. So both get cancelled. 0.5 plus x is 0.512 means x you find out. X is 0.512 minus 0.5, which is 0.012. Now substitute this x value here in the reactant pressure at 100 seconds. So how much you will get? Pressure of reactant. This is the reactant N2O5 at 100 seconds is 0.5 minus 2x you have to substitute. 2 into 0.012. So it is what? 024. So 0.5 minus 0.024. When you subtract, what will you get? 6. 9 minus 2 is 7. 4. Am I correct? 0. Remaining is 0.476. Okay. Now using this we can find K. K is 2.303 by T is what? 100. Log of initial pressure of N2O5 is what? 0.5. Pressure of N2O5 at time T is what? 0.046. 0.476. Now simplify this. Take the log value. And the log value of this ratio multiply by this. 0.5 by 0.476 is 1.05. So this ratio is coming 1.05. Now we find log of 1.05. It will come 0.005.